Okay, we're told to use a region. What's the region? This is the region over here. I strongly suggest you graph it out to try to figure out what the limits of integration are. So let's just start. X-axis, y-axis, y equals 1 looks like this. Y equals 2 looks like this. X equals 0. It's just the y-axis right over here. And then this one over here, it's just a hyperbola. It's going to be y equals 1 over x. And that looks like this, sort of. All right? And I'm going to say this is the region now. I'm going to put the points down for you. This point over here is going to be x is 0, y is 1. This point over here is x is 0, y is 2. This point over here is, y is 1. And then to get the x, you just put 1 down. That's pretty easy to do. This point over here is going to be, let's see, the y is 2. Well, if the y is 2, the x would be 1/2. All right? So if we're looking at this thing, the only way I could do what C doing without having to split into two parts is this way over here. All right, so let me write that down. And that's going to be a dx first. And what's the x going to go from? It's going to go from 0. And the x is going to actually equal 1 over y here. Right, it's that hyperbola, this thing over here. So x equals 1 over y. What's the integrand? It's e to the minus xy over 2. Now let's talk about the next thing, which is the dy's. Well, the dy's starting at 1, stopping at 2. Right, this looks like it's doable, and we're going to do the integration now. So let's put that down. So you're going to get e to the minus xy over 2. And so when you differentiate that, you're going to get, minus y over 2, with respect to x, by the way. So I'll just put that in the bottom to get rid of it. And the limits of integration are going to be from 0. And this pertains to the x, by the way, 1 over y. Let me repeat that. We're just doing this part right over here. Once that's done, I'll go to the y's. Let's put that down. And before I do that, I want to simplify it. So it's going to be minus 2 e to the minus xy over y, and we need to evaluate that when x equals 0 and x equals 1 over y. So what do you get over there? Minus 2 over y. I'm sorry, I forgot to put the 2 here. You're going to get e to the minus. Want to plug in 1 over y for that, it would just be minus 1/2. All right, let's do the 0 now. Minus of minus is plus, so it's still 2 over y. And if I plug a 0 in for the x, I get e to the 0, which is just 1. So I got that. So let's write that down. So this over here is quite simply going to be equal to 1 to 2. And then I'm going to write this thing down. This is the integrand now. I'm going to pull a 2 out. And I get 1 over y minus e to the minus 1/2. Actually, I'm going to write that as in a different way. I'm going to raise 1 over root a y. Let me see if I did that right. Yeah, it's okay, dy. Can I integrate that? I can. And what do you get? 2 natural log absolute value y minus 2 over root e natural log of the absolute value of y. The integration are going from 1 to 2. Let's plug it in. You're going to get 2 ln. Well, 2 is just, the absolute value of 2 is just 2, minus 2 over root e. Let's see, natural log of 2 again. And what's nice about the 1, both of those terms will evaluate the 0. So this is my answer. I'm going to clean it up a little bit. The first thing I notice is this over here, 2 ln 2. That's just simply ln 4. I'm going to factor it out. ln 4. What do you get? 1 minus 1 over root e. You can write that further if you want to write a little bit differently than that, you can. Root e. I don't think this makes it any better, though. Root e minus 1. I'm going to commit to this answer over here. And let's look at the case, see if we got what we need to get, which is the answer. Okay, you may want to look back over the work too to make sure that what's written down over here is what I said. 0 to 1 over y, 1 to 2, dx dy. Make sure this is written down correctly. Let's see if that's written down correctly. Let's see, I just factored 2 out, really the same thing. Yeah, everything's fine. We're getting to that answer too. Thank you.